So here, if we do not miss moment, we can go into basic input-output settings of this virtual machine. And in this case, this BIOS is provided by VirtualBox virtualization software. But in general, if you do not miss moment, you can also interrupt and go into settings of your physical computer as well. And then you can go into some settings there and change something, and then it starts loading first bootloader. And to show where bootloader is happening, let's try to restart it again. So this F12 comes message from this basic input-output system, but if you do not miss moment, you can also interrupt bootloader, in this case group. Why it doesn't respond to me? I don't know how to interrupt. In a normal computer, usually you can interrupt this bootloader put into your external, internal persistent storage like hard disk, just pressing escape key. Okay, let's try it once more, and if it doesn't work, then probably I have missed that moment. Okay, so we will skip that. And that's how unsuccessfully you can check how operating system boot starts. And then operating system takes over control of computer, and all other funny things what you do with your computer, then it is happening through the control of operating system. So next important part about operating system is thing called multitasking, and not all operating system do this. For example, FreeDOS is not multitasking operating system, but it's not general purpose operating system. You usually use it to do low-level diagnostics and low-level changes in your personal computer, because it allows you to access hardware directly without different kind of safeguards. But all existing general purpose operating systems allows to do multitasking. Early Apple iPhones didn't allow to do multitasking, but as far as I know, even iOS can manage multitasking today as well. And what is important about multitasking is that if you look on old-time computers had only one single CPU built into hardware. So problem appears: how can you do multitasking if you have just one single logical unit which does some things? An answer is following: that multitasking is actually abstraction. What really is happening here during time, that the same single CPU is doing different kind of input-output operations, reading from memory, writing to memory during time, and it does slices this time in smaller parts. And so these parts are split and managed by the system scheduler. And for one time, it may run like operating system itself, all these different services which are provided by your computer. But then it automatically, when time comes, and this time comes usually after a few milliseconds, and even though modern computers do not run with megahertz of their cycle frequency but gigahertz, I think that this switching time is still in range of milliseconds, not nanoseconds. So it runs few instructions to do something related to operating system itself. But if you click on your Microsoft Word icon and you load Microsoft Word there, then it loads inside memory and starts executing instructions for your Microsoft Word. And if something else is happening in background, then again it loads and does execution for something else, and then for something else, and until this loop continues. And if these single executions are happening and switching from execution to execution quite fast, in terms of not slower than a few milliseconds, for slow device like human, you may abstract these single executions in small slices at a time, and from general perspective you say that in this particular case my computer is running 3 different tasks at the same time, but it is just an abstraction when you blurry all these small switches which happened here and here and here in just in uninterrupted line here. So if these pauses for something else are small, you may say that it is actually just one continuous process to do this, to do that, and to do that. So this is just an abstraction. And what has changed for modern computers is that modern computers has more processors. And for example, my computer has 4 processors, so it can physically do 4 independent tasks at once, because there are 4 physical processors running inside my computer. But then question may appear: how many of such things are actually going concurrently? And other thing what also computer does is, I told you I think in previous session about these smarter devices which has direct access to random access memory. This standard is called DMA, from direct memory access. So graphical card, hard disks, network cards, they have their built-in processor. Of course it's not so powerful and not so general as processor, as your main processor, but they still can read-write in areas of this random access memory by themselves. For example, network card by itself just read-write bytes and specified subpart of memory by itself without affecting central processing unit at all. And hard disk may read-write inside memory as well, besides affecting central processing unit as well. And so that means that anytime your computer does such kind of input-output operations to read-write into random access memory for these devices, your central processing unit may be doing something else. some calculations and some general purpose tasks. And so that means that if in some particular task here, even if I have single processor here, this direct memory access is happening from hard disk or whatever, then this physical central processing unit may be switched and doing something else, some calculation in different task. And that is very great benefit for computers, because all these devices, which are not CPU itself, are much slower than the central processing unit. So every time your program is executing and then it needs to do some input-output operations, what usually happens is that these input-output operations are handled by actually another device, like network card itself, graphical card itself, or hard disk itself. And then central processing unit is actually interrupts execution of that program and starts execution of different program where some actual more complicated calculations may be needed. And that's how it works in single processor, and in these many processors it is just a little bit more complicated. For example, de facto standard utility to monitor status of Linux-based operating systems is utility called top. And of course you can open such utilities in graphical interface, like how it's in English, I don't know. I think it is GNOME System Monitor, which shows here approximately the same as I can see here, but of course graphical monitor is more powerful. It can show, for example, historical activities on my computer and other things. But these graphical monitors are very different depending on what kind of graphical interfaces you have on your Linux-based operating system. So therefore you need to learn different ones for different Linux-based distributions, but top is the same all the time. And if I switch to show, for example, activities on all my processors on my computer, I see here these 4 processors mentioned, and they show how much of time they spend using user space applications. It doesn't mean user as a Valdis. It means they do not have privileged access to the hardware. For example, it may be Valdis Jānis Pēteris if this system is used by several concurrent users as well. And by the way, for multi-user operating systems, for example, you do remote connection to this server and you do actual calculations on server and you send just text or graphical interface to this computer. This means that again each of different users just have different time slice depending on their priorities when particular user is running. So no difference than for single user system. Then it shows how much time these processors are spending doing system level activities like operating system itself, then how many of these processes are nice and maybe swapped out, and more higher priority processes may be happening, then how much time all my 4 processors are sleeping doing nothing, and how much time processors are waiting on external devices like hard disk, network, and other devices connected through the USB or whatever, how much time these processors are spending in high priority tasks, how many are, I do not know what is C, but here is how much time is stolen. And for example, if I go to virtual machine, and if this virtual machine does something very active, then it may happen that, for example, for virtual machine, some time is actually stolen. How this computer knows it? Because it has its own internal timer, which is scheduled after some fractions of second, many milliseconds. And if it sees that after next iteration, actual time, much more time has passed between these ticks, it knows that time was stolen from this machine. Yeah, and so here it shows top processes running, in this case, inside my virtual computer, and in this case running in my physical computer. And you see that one of top processes which are using all processors are Zoom application and VirtualBox Manager, Simple Screen Recorder and Pulse Audio Library to handle sound. But these are just top processes. If I check what are all processes running, so these are following, we can count them. So I have 246 processes currently running on my computer, and that means approximately 50 something processes are happening on each of these 4 physical processors, so this time sharing and switching between tasks is still very important, because if you do not have supercomputer with thousands of processors at your hand, then in most of the time what is called simultaneous execution or parallel concurrent execution is actually sequential execution with just small fractions of time or parts. And we can also show these all processes as a tree. As a root mover. So it doesn't show everything. Okay, and now about other part is thread. So thread is introduced later than these processes, and it is pseudo concurrent execution inside application itself. So initially, while applications and programs were not so bloated and feature rich, this pseudo concurrent execution was happening only inside these processes. But when developers developed large applications like Firefox, like Word and other things, what actually is happening is that there is pseudo-concurrent execution also in parts of some particular application. So here you have some process, but time which is reserved for this process is actually spent up with other small switches where pseudo-concurrent execution is happening inside this one time slice, and these are called threads. Why do you introduce such complexity? Because in general your CPU do not become faster if you start doing many things here with small switches, and it is also proved that when humans do multitasking, they also do not do it neither better nor quicker than doing these tasks in sequence. But what is important here is that remember that CPU is not only device which do some calculations, and every time you need to wait for something, then your CPU may switch to some other thread or process and do something else. So in total, if waiting time that it sleeps 97%, is the case that it sleeps just 50% of time, it will actually run approximately twice as fast because it's not sleeping so much, because anytime it can do something else, it does something else. So all these processes and threads, even for single user, do not increase speed of your computer, but they may increase time when this computer sleeps less, or central processing unit, and it does something more useful. And if we look, for example, on number of threads, and count also threads, so I have these 264 processes running on my computer, but if I count how many threads are there, these are 583. What was just big or small? And if I look, for example, where these additional threads are for some particular application, I see that, for example, different kind of heavy applications like VirtualBox, how many threads inside it, this means another parallel execution inside the same VirtualBox application, inside the same process, then many other threads here. Probably one was manager, another was actual virtual machine. Then we see many other things. So, and this is also how these virtual machines are working. Initially, personal computers didn't support virtualization. Mainframes, or real computers, which were designed as a proper computers around 1970s, they supported virtualization even from early beginning. But for personal computers, standards and how it could be done was invented before year 2000, but actually you could start using virtualization software in personal computers after year 2000. And how does it work? It works in the same as the switching between tasks. Only difference is that some of time your computer is actually running completely else. For example, here I'm running my Linux-based operating system, but when I also this run my VirtualBox manager, then it loads completely different operating system, and for some time it may run either Linux or Windows operating system in the same hardware, and then when time ends for this execution, of course it runs native operating system, and this is called the supervisor, and this is called guest, and that's how can you also do this virtualization. And virtualizations are two different types. Full virtualization, when this guest even do not know that it runs inside virtual machine, and that means any unprepared operating system may be run inside such full virtualization. For example, you can run Android operating system, Windows operating system, and it will even not notice that it actually runs from here to here when this hardware is provided to it. But usually it's not used because it's slow, and parallel virtualization means that actually this guest operating system notices that it is running inside virtual machine and does some better optimization, so you can't run virtual machines with parallel virtualization if they do not have support for particular supervisor for particular platform. So, and in most of times when you use like this virtual machine in this window, you do par virtualization because it is faster. And then these hypervisors may be different. For example, in VirtualBox it is type 2 hypervisor because I still run my operating system, and this hypervisor is just one of applications, one of programs with one sliced time slice running inside this operating system. But then there may be other operating systems which do not have general purpose operating system inside them at all, like Zen, which is actually Xen. And other operating systems, so only thing what runs directly on this hardware is this hypervisor, and then you run guest operating systems. And these kinds of hypervisors are provided in data centers when you run virtual computers on Google Cloud, on Amazon Web Services, Microsoft Azure, etc. So I think I showed this demo already. So now about memory management. So for multi-threaded or multi-executed operating system, one very important part, how it actually can be done and to be possible at all, is proper memory management. And for each physical computer, specific configuration, what kind of, and here I'm talking about random access memory in general, how much random access memory this computer has, etc., is very different. So there should be some abstraction inside the operating system that all these differences between actual settings of computer are ironed out. And so applications don't need to care about all the specifics, what particular configuration this computer has. And how operating systems do it? They do it introducing some called virtual memory. And virtual memory is abstraction of physical memory in a such way that applications which use operating system don't need to care about particular hardware. In particular hardware, you have specific amount of random access memory, which is this actual chipset which you put inside your computer. And then, because random access memory is never enough, it also introduces swap part, which is either a file or partition into your hard disk, into, let's say, HDD or SSD. And depending on your settings, for example, in this physical computer here, I have this swap partition put as a separate partition inside my hard disk, because today it's not so important, at least for Linux-based operating systems, swap file and swap partition is almost as fast as swap partition, but longer time ago, dedicated partition for this virtual memory worked better than swap file. But for other computers, and I think, yeah, here this extension of memory is created into swap file, into this place of memory. And why it is used? Because all this memory together, random access memory, which is fast but expensive, and swap file or swap partition, which is slow but much cheaper, all together in operating system is provided as a virtual memory. And then what happens is that you open some heavy application like Firefox or Word or LibreOffice Writer. Operating system says, okay, here you go, here is your virtual memory, let's say 4 gigabytes. But usually, if this Firefox is not used for months and it's not with some buggy JavaScript execution inside it. It doesn't need so much of gigabytes. And what actually happens is that inside of this reserved memory, actually in RAM, it probably uses only few megabytes, maybe few gigabytes. And then for some regular usage, so it actually uses something like this, and some part of it is put into random access memory, and everything else is put into swap disk, which is not so regularly used, or swap file, or swap partition. Then you run something else, like Word, again, operating system lies and says, here you will have, I don't know, again, 4 gigabytes. But what actually happens that only some regularly used part is put into random access memory. Some what is not used actually is ignored, and some part is put in different place in swap disk as well. Actually, to show it to the scale, swap part usually is bigger than random access memory, so it's put somewhere there. And all this cheating that application thinks that they have much more memory than they actually use is done by this virtual memory management inside operating system. And in most of times this works pretty well. And operating system actually may overcommit or promise more memory for all applications than it even physically has, not only counting random access memory, which is chipset, together with this file or partitioning disks. So it may be that here promised is, let's say, 60 gigabytes, but actually it has, let's say, 8 gigabytes here, and let's say 20 gigabytes here. But until it's something like overbooking of your rooms in hotel, and overbooking that you just hope that not so many guests will arrive on your conference or whatever, and everything will be okay. And if we can check it, for example, in some statistics, so this monitoring tool for this Odo.lv web server, and if we look on where is system memory, so committed memory, not so big here, 3.6 gigabytes, but let's check some not so great memory like tools. And here is good example. So this is server with small size of memory. It is tools.odo.lv. And you see here that random access memory for this server is 0.4 gigabytes. Gigabytes actually. Let's say 500 megabytes. Then it also has swap disk, approximately the same. Another hundreds of gigabytes. But this graph shows what is actually committed or reserved as available by operating system. And you see that here committed part of memory is much bigger than it actually has. So committed memory is 1.4 gigabytes, even though it could actually probably can handle much less. But until neither of these applications actually use so much of they had reserved, because operating system usually just overcommits it, and for any stupid application it usually says here is your 4 gigabytes of memory, just use it. And of course not all applications uses 4 gigabytes of memory. And then operating system does these calculations and faking. It calculates this memory management in a such way that what for application is considered as a large non-interrupted area of virtual memory, actually, because when these applications do their activities, some part here is more active and some part is less active. So all these parts of memory are quite frequently swapped between random access memory and swap file or swap partition. So it becomes fragmented. But all these fragments are cleaned up with these connections between this memory, and applications think that they have continuous memory starting with some small number here and finishing with just some large number here. But what actually happens is that some of these parts are somewhere here in physical hardware, some of part is memory somewhere here in physical hardware, and all these mismatches here between this continuous virtualization of memory and actual management of memory is provided by operating system. So, okay, before we go forward, I'm looking in chat, which I closed when my computer crashed. So, if you have powerful graphical processing unit, you can do quite a lot of calculations in your graphical processor. And the important part is that these are quite completely different animals. Central processing unit is, especially if you use IBM PC compatible or this CIST architecture, complete instruction set processor, because these processors tend to be much more powerful what kind of operations they can do inside these numbers. So all processors just work with numbers, but length of these numbers tends to be bigger, and operations what can you do with these numbers tend to be more high level, more elaborate. But for graphical processing units in general, they were invented just to deal with many dots on the display, and of course these dots are represented as numbers inside graphical memory, which is just part of total, and of course graphical memory is another part of total virtual memory operating system handles. So these numbers may be smaller. For example, if you usually it's still quite large, but usually these numbers are not longer than 32 bits, because it is enough to show 16 millions of colors, and so usually that's enough, and these usually handle 64 bits. But what is very important here is that this central processing unit is very sequential device, numbers in, numbers out, with greater speed and with many different possibilities what can you do with these, but these are sequential. But for graphical processing units, they are not so powerful, but usually you have thousands of concurrent processors which may deal with these numbers, like write zeros here to make black color, write other number here to make red color, etc. So this graphical processing unit is much weaker in terms of their performance, but usually you have several thousands of weak processing units, let's say approximately 1,000. And sometimes when you can do parallel execution, parallel tasks which do not depend each to other, and for example for display, many of pixels do not depend each on other, you actually can do it faster than with this general purpose processor. And there are some of number calculations again, which can be executed in concurrent, in parallel, that these 1,000 weaker processors and graphical processor unit actually may work faster than this powerful but just single or 4 processors on your computer. And therefore you may compile your applications if you know that you have this specific graphical card with this particular graphical processing unit, that some of calculations actually on such design when you have many weaker processors, maybe working faster when you have few but more powerful processors. So here it is RISC architecture, definitely. It's much simpler, but you have many processors. Only problem is that you can't do any calculation concurrently and independently each to other. And particularly about clocking, it depends. Everything depends on your narrowest place of your computer. If you open your monitor and your processors are running close to 100%, then your narrow place is your processors. So if you will clock them faster, they will do this calculation faster and it will work a little bit faster. But if not, performance of your processor is not narrow place and this bottleneck is somewhere else, like read access to random access memory, read-write access to the hard disk, then of course you need to improve that part. For my early computers, like 25 years ago, I actually used overclocking and I made these processors faster. But today, usually, if you do not have very bloated operating system and applications, your processors are not the slowest part of entire system. And therefore, overclocking is not so important anymore. It still may be important, for example, if you use CPU-intensive applications like 3D games and other things, but otherwise, usually, overclocking is not so important as it was many years ago. And yeah, our overbooking, it may be that some of these temporary files which you have in your dirty file system, maybe also some of these files where you store some kind of data. It may be actually true. So next thing what all normal operating systems provides as a service to these applications are file system. And particularly for Linux-based operating system, management of file system is also part of the kernel. In other operating systems, management of file system may be not part of kernel, it is farther away from hardware, so with less permissions. And I hope you remember that hard disks are block devices and everything is read-write inside disk in blocks. Of course it is magnetic disk. These blocks are just some circular parts around this magnetic plate with very precise rust on it. But if it is, so it's HDD or magnetic disk, but if it's SSD, it's still just specialized chips. And then you can look on this memory as just an array of cells. And you can read-write not just a single small cell in it, but you can read-write block, and block is usually 4 kilobytes to maybe 4 kilobytes. But such disk, of course, it's hard to use because it means every time you read-write something from it, you need to say, please read data from block number 35,000 till to 64,000 and provide me these data. So neither application uses such approach if you do not use some disk utilities. What it uses so-called virtualization and abstraction of disk, which is file system. And file system allows you to access these blocks of disk using paths to the file. So each file has unique full path where this file is located, and then from this full path you actually know where exactly this file is located. For example, here is some very large disk, Windows 10.vdi, 21 gigabyte of data. And so full path of this file is /home/valdis/virtualbox VM Windows VDI. So, and this is abstraction of this file, so I can reach content of this file mentioning this particular name. And I can also, what operating system provides me is that I can mention this particular name is with full path. And full path means starting from the beginning of this address space. And beginning of address space in VMS-based systems like Windows would be name of the disk, colon, backslash, blah blah blah, backslash blah blah blah, backslash blah blah blah. And similarly for Unix-like system, first, instead of backslashes, say use slash. And second, it is more general, so it doesn't count disks by name, because each disk may be mounted on different folders. So root folder is non-mentional disk, but just this part. So this slash means root of my file partition. And also, if my current folder is following, pwd means print working directory, I can also say just relative path to it, like show this particular file or detailed information of this file. And then I can be more ceremonial, because this means the same as that. But here I say more ceremonially that I know what I'm doing. Please show me the same file starting from current folder. And in Windows, of course, current folder would be .backslash. And so and here is this inodes of this disk or its addresses, and here it is entry point of these addresses, but I don't remember. I think I need to be root user for that. And because this is large file, here is number of blocks inside disk where actual content of this file is located. So when I say please describe in this index entry, which is called inode from index node, where actual content of this file is located, so here are range of blocks. Because it's large, it has some fragments inside it. It's in blocks from here to here, in blocks from here to here, in blocks from here to here. So quite many. If this file is smaller, let's say this file is small, describe this inode of this, it will be much slower. So everything fits into one portion of this block. So, and then of course these file systems may be different, and different file systems provides different services. And particularly for Microsoft Windows, one of index tables, which are still used in formatting way, how you format these blocks of disk is file allocation table, doesn't have any security. It has one single file allocation table of the beginning of the disk, and then it says that actual content of this file with this particular path is located here, here, here. So nobody uses this except for removable devices because it doesn't have any security. And sometimes it is good because when you need to exchange some data with your friends, for example, you create file with security and your username is Jānis, and then you give this USB stick to Pēteris and his username and unique user ID is different from yours. He or she cannot read this file because he or her doesn't have access permission to read this file. So still widely used for removable devices because it doesn't have any security built into it. What are the disadvantages? Because this file allocation table is quite short. If you have very large disks, then minimum amount what you can address through this index entry is quite large. So if you have very small files, then your disk will be very poorly used because these addressable blocks of disk are very large, maybe many tens of kilobytes, for example, for some terabyte disks. So in Unix systems, usually you use so-called index nodes or inodes, which make this idea more elaborate because it may have index entry of index entries of index entries. And so initial part is similar to file allocation table. You have some index entry with data which says that file with this path, and the path of file of course is its index entry, how you know uniqueness of this file, may be located in these blocks, in these blocks, in these blocks, but then there may be indirect that if file is bigger, then it may loop into another part of these inodes, which says that other part of this file is actually located in entries of these nodes. So that means that here you jump from index entry to index entry, and then in that index entry you similarly as here start read particular blocks of file from here to there. And then if file is even bigger than that, you have index entry pointing to index entry pointing to index entry, and then these index entries pointing to file. And with such approach, these addressable blocks may be much smaller than for file allocation table, and so you can use your disk space much more efficiently, because if you have small amount of data and your address space is with very large blocks, then you have quite a large of blocks unused inside your space. And so this is de facto standard how different kind of Unix-like system works. Then there is NTFS, or New Technology File System, which is currently used for Microsoft Windows. So it is still like file allocation table, but it is more extended with permission control. Also it has several index places, because if you lose index you can't read your disk at all. So it is more economical, so address space is bigger, etc. And then usually file systems again have some cheating inside them. For example, if you have some binary data and you need to read and write very many zeros for your data, or very many ones which are repeated, almost all file systems actually allows you to cheat, and the index entry may say something like this. Let's say 10,000 zeros now, or 1,000 of ones here. And this is also done immediately by file system. So if you have large empty files, actual consumed content of this file may be much smaller if they have quite large of redundant data there. And then of course you may have different kind of partitions and journals. So if we talk about partitions, default tool for Unix-like system is in command line cfdisk. Okay. So list block devices lsblk and then cfdisk dev, this one. And here there are actually several file systems inside my physical disk. These are called partitions. So it has one partition with size 24 gigabytes, another partition with 400 something gigabytes, another partition with 400 gigabytes. So first this is split into 3 different parts, and then inside these are particular file system, Linux file system, which is called ext4, here it says file system type. And for swap, file system is swap. But you can also use another tool in graphical interface called gparted. And why you see quite many G's in different kind of utilities, it comes from GTK graphical libraries. Initially it was developed for GNU image manipulation program called GIMP in short, but then these graphical libraries were also used for many other tools, and so this G usually mentions that this graphical application is built on top of these GTK graphical applications. And with this you can do partition your disks using graphical interface. And so here you see that this is boot partition, this is where operating system will be booted or started reading this part for it, and many other things. Sometimes you may need gpart, for example, if you use a virtual machine and you extend disk for virtual machine, which is quite easy, but it will actually not be used by your virtual machine because these partitions then we need to extend it to more data available into your virtual disk. And one more thing about these things, about delimiters. So, ceremonial way to say for some is to use such notation. Dot and slash means current folder, and dot slash means parent folder. But particularly for Windows it is complete opposite, so it is backslash and then something like this. And you should remember that, for example, when we talk about, if you, for example, do something in Microsoft Windows in command line, that when you convert this internal structure of file system into just string showing path to the file, then these delimiters and starts, how you split up these entries, folder inside folder, are two different ways. So that, did I tell everything I wanted to tell about file systems? And then some of you maybe are using this, I don't know. Also operating systems provides services to create one single file system using several physical disks. These are called volumes of disk. So, and particularly for Linux, this standard is called LVM from Logical Volume Manager, and that means if you have one disk, another disk, and another disk, you may create one single file system as an abstraction on top of these several disks. And you shouldn't confuse them with RAID disks, which is service provided by hardware, not software. And RAID disks means that if you have specific hardware, and actually RAID also may be provided by operating system, you may add redundancy of disk in such way that content of these disks somehow overlap, that if one of disks breaks, you still can recover the data using redundant data in other disks. And these RAID standards are different. Like mirror means you have mirrored disks, but the problem with it is that you have to have twice as much hard disk space to store. Let's say for 1 terabyte of data, you need 2 disks, each of them containing terabytes. Therefore, they have other tricks that redundancy is not duplicated but a little bit less. For example, RAID 3 or 5 means that only some redundancy is put in disk, and so your redundant data is not twice as big but approximately 1/4 or 1/3 or 1/5 as big, etc. So these services are also provided by operating system. Then operating systems also provides services to the network, but I will not go into much details for this today, because we will have more detailed discussions about networking later. But network, of course, is a very important part of modern computing, because usually for most of general purpose computers, the usability is much worse if these devices are not connected to the network. And you may have local home network, for example, to share a shared disk between devices. You may have connection to the global network or internet to do these things, but I will not go into these details. And also, operating system provides file system services through these networks. And leading standard for Microsoft Windows protocol is called SMB, from Simple Message Blocks. But in jargon, these are just the Windows shared file systems. And for Unix-like systems like Linux, MacOS, BSD, a de facto standard is called Network File System, or NFS, and it is just a shared file system for Unix-like systems. And then important part about operating system is user interface, because in most of times that is part of operating system to provide usable interface to deal with different resources provided by operating system. And here you have 2 different choices. Some of you may see only second choice yet, that is graphical interface, but very important part is also just the textual interface, where you interact with your computer using text. Why it's important? Because when you work with remote computers with slow speed, etc., then it is much more efficient to connect to remote computers than sending many pixels on your screen from remote computer. And particularly for Microsoft Windows operating systems, before they introduced PowerShell, this command line interface was quite weak. on many of advanced tasks you still had to do with graphical interface. But starting with Microsoft Windows PowerShell, even in Microsoft Windows you can do quite a lot of tricky tasks in Microsoft Windows as well. And what is also important part of this text interface is that it allows you to do automation, because everything what I do here in this terminal for example, here I can look on history what I did here. Let's write these commands. Yeah, I should add. Another thing you can add, at least in Unix-like system, is your home folder, which is shown as a tilde. And then suddenly I could also do everything just by executing particular script with these commands. And that is very powerful feature as well. And for Microsoft Windows it would be .bat files from batch commands, but also you can do Windows PowerShell as well. So, and typical command line interface is something like this. You just write text as a command to computer, you get text back, you make also called pseudo graphics, and useful tool here is Midnight Commander, or MC in short, because it allows you to do more try and error approach. You can navigate through the files using either mouse or arrow keys. So it still describes everything, just the text as a characters and pseudo graphics here. So all these lines are specific characters. For example, okay, I can copy it as a text. So you see here that everything here is just a text, and this is specific character, fox drawing lie down and right, and this is specific character, vertical line, and this is particular character, horizontal line. So everything here is described as a text, so transmitting data from remote computer to your computer becomes much faster. And you already get used to it, so I will not describe it in details, but of course graphical interfaces also have their strengths. And one of the things is that it's more intuitive for beginners, especially when you need to do multitasking. Switching from window to window is easier in graphical interfaces. And as I told you here about computer history, first graphical interface was invented in Xerox Palo Alto Lab, or Xerox in Latvian pronunciation of English. And then when Steve Jobs visited their laboratory, he was very excited about such approach, and so he also introduced it into MacOS operating system. At that time it was called differently, MacOS something. And of course Microsoft Windows follow, etc. What is not so good about graphical interfaces is that if you do not use much of menus and do not hide these things, and for example that is one of the reasons why Microsoft Word start hiding all of these buttons, and these are somehow context sensitive, because if you have very many options and you want to show them all, then they take quite a lot of place on screen. And if you hide them, then again problem is that you don't know what this tool actually can do, because these are hidden options. So then graphical interfaces are not so good when you need to do different kind of options. And so more details about command line interface and inputs and outputs is that what also should be very useful for you, and some part of it will be also useful for your practical exercise, is to understand how text-oriented programs work. For graphically oriented programs, everything is around events. When you drag drop your window, when you minimize, maximize, when you click somewhere, you generate events. An event is just data which describes with some numbers what actually happened there. But for command line interface for text, all this computer still works from 1950, 1960, is that you have some input, output, and you do. So in real life, here is a snapshot of some picture from internet, is that engineer may be described as a black box or yellow box in this case, that its input is problems and coffee, and output is solution to the problems, and side effect is like sarcasm. And this is just paraphrased idea of some mathematician who told that mathematician is device which converts coffee into theorems. But in command line world, when you run commands inside terminal, then again many of commands can be described as a black boxes which takes some input, provides some output. And input is connected to the keyboard, and it is also shortened as a standard input or std in, and if you number it, its index is 0. Output is standard output or console, or what you see here. Okay, this is my console then. And it actually has two outputs, also called standard error output, which is also console. And so you can write some text, provide it as an input, then it may do something with this text and provide this output either into standard output or standard output, or do something else. And before we go in details, so about this terminal. Why this terminal is called terminal emulator? Because real terminal So this was real terminal 40-50 years ago, and terminal is not computer. So computer at that time, and we are talking about real computers which today are called mainframes. was large box or several large blocks in some computer room. And of course it had central processing unit, random access memory, persistent memory like hard disks, etc. So actual processing happened into this large box into this room. But this room probably was too hot, too noisy for people to live always there. And they connected to this computer using so-called terminal. And terminal is just cut-to-dry tube display and keyboard. And later, when graphical terminals were introduced, of course mouse as well. But this was not computer, it was just device which sent, if it was text terminal, text or characters from this terminal from its keyboard, and text back, and it was shown here on this cut-to-dry tube display back. And when graphical terminals were introduced, then of course they set text and mouse events to the computer, and it sent pixels back to show graphics on the screen. And they had some small processor built inside them, but of course that processor was much weaker than that processor on real computer. Only thing it needed to know is, for example, how to show particular pixel on this graphical display, or how to show particular character on this textual display, and how to send these things. So it was not real computer. Only thing it could do is to handle properly keyboard presses into characters sent to the real computer and back. And so for real computers, real terminals looked like this, and these were connected with different kind of connections to them, but in general they just sent text forward and backward. And later, when graphical terminals were introduced, text and mouse strokes to the real computer and graphics back. And so today you usually do not have such specific purpose built hardware to interact with your computer, but you can open this virtual terminal or terminal emulator which do the same. You can send text from your keyboard and it sends text back to your computer. Only difference is that now this terminal here is also particular program and application running on my computer. But if I do remote connection, like remote shell connection to server odo.lv, here command prompt of course is different. I'm now Valdis at Odo, and I send commands here to computer. Actual calculation now is happening not on my computer, but it's happening on this remote server. And again, I'm just sending text forward and getting text back. So, and to illustrate interaction between this terminal, I will show you, hopefully it will work. So I can call particular application called vSpeakNG, and for example say hello. Do you hear hello? Great. So what happened here? First word in this command line interface means that I try to execute command, and then many other words may mean different information depending on what I'm doing. For example, I can open some GUI-oriented or graphical applications from command line as well. So Multipad is similar text editor to the Notepad in Microsoft Windows. And if I say like Multipad add another word here, in this case this additional word will be used as additional information to open for editing this particular file. So currently this file is empty, but I can write something, save it, and now when I open this file with this particular content. So these additional words are used as parameters to this system. It's something like here, command echo, blah blah blah. So echo means say something in terminal, or echo back from real computer to my terminal. And if I add several words here, it says tralala here back to me. And similarly, but here it takes only one word as parameter. I can say do something like this. So that's how you can add additional information for these programs for execution. There may be other parameters, like I can say it in Latvian. And then it says something like this. And by the way, here, all what I have demonstrated here so far, this sound is something like side effect or sarcasm for this engineer. So programs may do more than you can inspect them just using text interface. And in this particular case, I'm ignoring the fact that side effect for this application is producing sound into my sound card, but I can still manage it using command line interface. And then it may happen that with proper parameters I actually read this text not as a parameters here, which I preset before I press enter key, but I can just write and so now it reads from the standard input, which is keyboard in this case, and produces some kind of sound. And if I say it is English again, something like this. But that's not all. Programs which read something from the standard input, this stream of characters, this input may be redirected. And if I create text file like test.txt with following content, I can say espeak g read from this file, and smaller than means instead of standard input now use content of this file as an input. Then it can read from this file, and so far I saw only side effects like sound, but I also can say print something into output. For example, say pronunciation rules, how exactly it is pronounced. And I can say this, for example, redirect in other file. So smaller than means read from this file, and larger than means instead of standard output redirect to that file. And then you can append to it larger than. Then it appended more content here. And then That's about parameters and inputs outputs. Then you can concatenate programs using so-called pipe. For example, ls means list content of the folder, but I can use vertical bar, which means pipe output of previous program as an input to the next program. And then output which was produced here to list these files was used as an input for this next program. And this is a very powerful feature as well. For example, before that I could use count how many lines there are. And do many different kind of calculations. And then about error output, let's say. So this particular output is error output, and by default, again, it is just my console or this virtual terminal. But to see that this is different output than like this output, I can say redirect second stream to, and then I do not see this error anymore. But if I check what is inside this error, I see this content here. So that's about these things. So, and then operating systems provides other services as well, like security, but I will just mention it for you to remind that it is also important part of operating systems, but we will talk in more details about security later. So user account management and security management, for example, allow access to not allow access, different kind of settings, what you can do in the network, all these are usually part of operating systems. And then of course there are a bunch of utilities which allows you to do these things. For example, if we go back to these layers between hardware and software, so here at bottom is actual hardware what we have. Here we have this kernel part, which is in most systems device drivers, but for Linux it's also file system, networking and some other part. And then you have this operating system, but operating system also has different kind of utilities which are put together when you package your operating system. Particularly for Microsoft it will be, let's say, WordPad and Notepad, editors, different kind of utilities, blah blah blah, and this part of utilities also may be very very large. And so why they say that, for example, you can't say that Linux is operating system, because Linux is only this part for Linux based operating systems. But there are many other parts, and particularly for Linux based operating systems, because these are more layered and put together. For example, for these utilities which I showed inside your terminal, they come from this GNU tools. And GNU is that operating system which in theory may be independent system besides Linux, but in practice is usually not, because all these GNU tools or utils are part of something else. Then when we talk about graphical interface for Windows, everything is super integrated, etc. But for Linux operating system it's not the same. For example, de facto standard how you implement graphical interface is libraries called .x.org. So this is for GUI. But again, you do not use x.org directly, you use different kind of graphical libraries and frameworks to use it. I already mentioned GTK is one of them, KDE is another, and there may be LXDE and other environments. And then, when together with these things, you again make have different kind of utilities on top of them. And then you can have different kind of applications like LibreOffice, Firefox, or Chromium, and other things. And this part usually is not part of operating system anymore, so this part is usually apps. But some of these apps are built in, because if you install, like in your virtual machine, you installed this Xubuntu operating system, you had this part already put inside it, this part already put inside it, this part already put inside it, most of this part, and of course this part. So that's what makes operating system, and that's why it's called Xubuntu or Xubuntu for Americans, because there is much more than just a Linux kernel, which is important part, but not only one. And if, for example, you follow Richard Stallman and you say that this system should called GNU/Linux or GNU plus Linux, again you pay attention to this layer of these tools, but then you do not pay attention to this layer, and there of course are other libraries which you can use for graphical interface like Wayland coming from Canonical, and then there was other one I don't remember, but this is still de facto standard. And then of course you ignore many other things here like LibreOffice, Office Suite and Firefox web browser and other things. So what you particularly get for this operating system is very heavily dependent on what kind of operating system do you have. For example, if it's Android operating system, then this picture is quite similar to personal computers, but then differences are in top layers. So you have specific hardware, which is not IBM PC compatible anymore, and you still have Linux kernel on top of it. But that's it. There is no GNU utilities, there is no LibreOffice, etc. Then you have Java Virtual Machine implemented by Google, which today I think is called ART from Android runtime. And then you have these Java apps on top of it. So everything in Android is like this. If you have iOS, so that would be Android, then you have again different hardware. Here you have their modified kernel coming from next operating system. So it's modified BSD kernel. And then you have the GUI apps, and then these apps which are completely different than for Android apps. So that would be iOS. So again, it is different set of operating systems. And yeah, so that's about important part of operating systems. And before we make breaks, you can ask some other questions or comments if you have any. Okay, I think that we can consider this that there are no questions or comments. Questions or comments? So now let's look into your second exercise for your homework. And if you are power user, then it shouldn't be very hard. If you are not, then it may be tricky. And first I will show you how you can do test automation using command line interface to make all things faster, and then I will try to show you how you may try to do this in Windows or any other operating system. So in general, task here is to deal with different kind of types of files, and actually that's it, different kind of files. And what is highlighted here, different kind of documents and archives. So you download this file, and if you are Windows user, I will show this later. So I have not checked it recently. Microsoft Windows may not understand this particular archive format, but it is de facto archive format for different kind of Unix-like systems. And I will show you later. If you try to do with this Microsoft Windows, I think best open source, legally free to use archive manager is called 7-zip to use it. And also I will not try to show everything about actual content, so when you download it, you get some archive, but I will show you a little bit different archive. And this little bit different archive, you just extract it. So shouldn't be hard. And what you see here is bunch of folders. And inside folders are folders, inside folders are folders again. So first trick here is you should have enough skills to find actual files here in many folders. If you do it improperly, like cheating, you can do these features of Archive Manager. You see, these folders are empty. This folder is not empty because it has some size. And then here, many empty folders. This folder is not empty. This folder is empty. We see some document here. And similarly here. But of course you can do it in better way, like to search all the files here, and I don't know how to use this one. What I know is the same utility which works in the same way on remote servers and on MacOS and Linux based system is a utility called find. And if you do call it without any parameters at all, it finds all non-hidden files and folders. I didn't mention what hidden is. In Unix-like system it means it has a specific name, or name starts with dot. And here, of course, it's important that dot slash means current folder, but dot slash dot blah blah blah. So this will be, if there is some blah blah blah, so this is part of name of file. and if you create such file, you don't see it by default because it's hidden, but if you switch show hidden files, Ctrl H in this file manager, you see this file created. But you may be smarter than that, because you are not interested about anything, you are interested about files. And so you can do something like this. Find type is F, and then you see only files. Unfortunately, here in this demo example there are only 2 different files. And then you can open them. You may try to remember, now it's folder A7, now it's folder B3, and subfolder C5, blah blah blah, but you can copy paste and just say LibreOffice, which is this open source office suite for Linux based operating system, and pass to this file. And you see some content here. And then copy paste it again, write libre, and open this, and of course you need to type it correctly in second time as well. And you open as a file, and if on your actual exercise these files will be more, so it will take more time. It is doable, but you will need to waste more time. And you can automate many of these things by executing following command. And what does it do? So semicolon means end of current statement, end of something. And I showed you what find dash type F means. It means here, it means find all the files. And because we don't need this anymore, maybe I will just delete it, so my example will be easier. But then, particularly for bash command line interpreter, you can put output of one command as an input of next command, and in bash you write it as a $, and then these brackets. For MacOS users, probably because their system is based on BSD, it may be like these backticks, how these are called. Grave accents, official Unicode name, or grave, or backwards apostrophes. Problem with these backward apostrophes is that you have problem putting command inside command inside command. But for bash command line interpreter, so you say this is iterator for E in list of these found files, and it will take this output here. Do following, call LibreOffice and pass this parameter to LibreOffice to it, and then done. So then, even for many files, I can do it in more automated way. And I just collect all the content from these files. And in this small exercise, that's it. Actually, when we talk about convert options, you could do even something like this, but unfortunately it doesn't work well for all conversions. You can just take text out of these documents and print it. I will show it later, but unfortunately it doesn't work well for all kinds of Office documents you may see. So with that I found first part of, or first task of this exercise. So I collected all the content for different kind of documents. I found them, I look into them, and then I can save it. So what was my unique ID? This is my unique ID. Yeah, was some second exercise. I think that should be like this. 2.1txt, yeah. And I will upload it later. And second part is to learn how you can save the same content in different formats. And leading format for non-editable or at least hardly editable and platform independent format is PDF file. And of course, what can you do? You can close this, open it with, let's say, LibreOffice Writer, and press this button and save it as a PDF file. Quite a lot of clicks. But you can automate it again by here what is not told is about current folder. And I mentioned it, current folder is like when you do clicks on these graphical file managers. Current folder is quite simple one. It is what you see somewhere here, so that is your current folder. And similarly for text interface, for example, if I say list in current folder here, I see something different than if I go to my home folder and list here. So because I saved my txt file here in my home folder, not in downloads folder or whatever, then of course when I call this command, so here are many words. First word always is executable command. So I call this LibreOffice, but I don't even care to see graphical interface for it. I add parameter, don't bother showing me graphical interface because it will just make things slower. But I say convert to PDF on this particular file. So in such way I can call LibreOffice as a library without showing graphical interface at all. Not ABCD, what is my... So that was just an example. Actual file for me is this one. And I double click on it and then I press Shift and Insert to copy paste it without using right click here, copy and paste with this context sensitive menu. And then, because it just changes by default when you use this LibreOffice as a library without graphical interface, it just changes extension of this file. I need to rename this file because it is considered second task, not first task. So naming here should be not 2.1 but 2.2.pdf. So I do something like either right click rename on graphical interface or something like NV. I think in LibreOffice there is also option to say what name of output file will be, but I didn't bother to learn all of its possibilities. For example, you can write one LibreOffice and that is manual for LibreOffice to work in command line, or LibreOffice -H. So it shows you, probably man shows more information because it's full manual, but maybe it's approximately the same. Now I created in my home folder also PDF format of this text document. So if I need to convert just single file in such way, then of course graphical interface is not bad. But if I need to do such conversion for a bunch of files, then command line interface and automation can make great benefits. And similarly, I need to convert it to HTML format. Again, you can make it manually by yourself, but we will convert this. What was the name of my file? And I have also created simple HTML document with the same content. Now I have to put these documents into some folders. And here you can do it manually, but it will not be fun, because you need to create parent folder F1, with child folder F2, with child folder F3, with child folder F4, with child folder F5, 6, 7, blah blah blah, till the folder 100. You can do it like, and then do this and just 100 times and you will be done. But again, you can do such repetitive tasks automatically in command line using iterator in this bash command line interface. You iterate from E from 1 to 100, make folder F with E, change current directory to this folder and repeat. And so if I do it, wait a minute, and I see that my working directory is now this one. And I have to put my created files there. And again, you can do it something like, here are my created files, 2 to HTML, 2 to PDF. And I have to move them inside folder, inside folder, inside folder, and I need to double click 100 times, which is not fun. But here you can use this midnight commander. For example, when you open it, it uses as a one of Windows current folder. And if you start from beginning, you can also do change to it much quicker, change directory F1, and then use auto completion feature of bash command line interpreter, which is tab. And if there is only one possibility to auto complete it, then with each tab it auto completes the next only possible choice. And I just allow for my keyboard to auto repeat this, like I change to current directory very easily. And then I can open Midnight Commander here, And here, let's say cd without parameters, which is my home folder, and now I have my home folder as one current folder in this Midnight Commander, and this folder inside folder as another, and I just put them inside. I do not know, copy or paste. So here Midnight Commander shows you it is all specific tasks are done with functional keys of your keyboard: F1, F2, F3, blah blah blah. F1 is help, F2 is menu, etc. And I copy them. If it is very tricky to you, we may think how to do with graphical interfaces. I'm not sure that default file manager for this Xubuntu is Putsuman FM. I think that default manager, what probably you are using, is file manager called Tuner. So you can do something like this: cd F1 command line, press tab to autocomplete, and you are done. And then you call Tuner in command line. And of course you know how this folder inside folder as a current one. Then you can open another tuner and put these two files inside that one. So again, if you are advanced user, sooner or later, eventually, you will do this. If you are not advanced user or just a hard-working guy, then of course it is doable. You just need to double-click 100 times and you are done. So, and with that, we have dealt with this file structure or folder structure of this thing, and then we need to create archive. And for these graphical managers, you can just right click and say create archive. Unfortunately to you, now requirement is to create a zip archive, which is easier for you, probably more familiar. And name for it should be zip. Or if you do it in command line, you call it in following way. You call zip this archive manager, you say be quiet, don't show all these files, do it recursively, or if you have folder inside folder, of course, compress everything, and create archive file with following name and start with folder F1, and it is the same. And if you don't do it quietly, then it shows all these files and folders which are actually compressed. And then I think I have demonstrated what you need to do, and then you upload these two files with the same username and password. You need to upload second exercise first task, this file, and second exercise second task, this file. Oh, I also made a mistake. zip.zip name. This name is proper one, of course. I think I made mistake when I did it with graphical manager here. If I do something like this, then if it's zip file, it should not have .zip here. Yeah. And that's how you do it in Linux-based operating system. And how you should learn some new things for automation to deal with some tricky but repetitive tasks. In this and some preparation is already done. And again, I will not download actual file. I will use demonstration file. Where it was located, no idea, somewhere here. So I got this file, and with 7-zip archive I will not extract it there because it will create many folders on my desktop. So what I will do, I will create new folder somewhere here. How I create new folder? Probably. But if your standard Windows understands what this archive is, then of course everything is fine. And that's okay, because TGZ standard means first you put many files in single file using tar packaging format, and then you compress it using gzip format. So then again we need to extract here again, and then to make things easier. And now we can try to search. Any ideas how you do in graphical manager? I don't remember. So this is find utility in Microsoft Windows, but I have not used it for quite long. And here I don't remember. Let's look on. What is this? Okay, you will figure it out yourself, or you need to do, but I'm just surprised that there is no good right click just to search in this particular, what is here? Okay, here you will learn by yourself, and when we will have questions comment session you will teach myself. But because I somehow know where these files are located, these were somewhere where these were. So one of these possibilities, it's either under A7, B3, B8. You look here on archive, and similarly probably you can look. So I deleted it incorrectly. A7, B7, C7. So you open it. With more recent Microsoft Office this also should work, and you similarly collect this necessary information. And when you can collect it, of course you can use only graphical interface. For example here, when you collect everything, and another file was B3. You collect all these files. It should be sorted, so should be in the following way. And you can say, this has wrong interface. I like standard toolbar. I apply it all. And you can save it. Let's say in homework. As a txt document, and here you also say text, but my ID was, I forgot. And you save it as a txt file. I think I changed this current folder. Yeah, and then you save it also as PDF file, and then you also save it as HTML file. You can double check that this looks like, oh, I do not know how any PDF viewers there. Yeah, so I think I saved only as a PDF file. Again, yeah, in this folder. And then about creation of this folder inside folder inside folder. One thing you can do here, I don't know, did I mention it in this homework or not? Maybe here. You may create your Microsoft Windows much similar to Unix-based system by installing Bash command line interpreter in Microsoft Windows. And to do that, you may need to install advanced settings for Microsoft Windows and Windows subsystem for Linux. And then you have features something like this. This is not that. And here I have virtual machine. It's not actually inside virtual machine, but it is command line interface inside Microsoft Windows. Only problem is that here it has folder /home/student, but if you will look in real files and folders where it is located, it is somewhere in in deeper settings of your home folder. And so for iteration, I have not done it. Let's check this out. My copy paste doesn't work. So instead of do echo, we say, I don't remember, cd is the same, but create mkdir. I did this. Let's double check what I did here. First I needed to add f's before that. So that worked, but changing directories didn't work. Such brackets and no semicolons. Do and brackets. Why this CD doesn't work? Okay, if that doesn't work well, you put it maybe something like this. You will figure it out yourself. In general, it is possible. I showed you some hints. And if nothing else works, then you will need to work a little bit harder. And yeah, if it is real problem to you, I may spend a little bit more time and I can prepare it more properly for Microsoft Windows as well. So it is theoretically possible. Practically it may be. So as far as I can tell, this should work, but because I have not written command scripts for Microsoft Windows for a long time, of course, even just dealing with syntax is... we are running out of time, so if you have some questions and comments, these should be short, and answers also should be short as well. Do you have any?